Problem number 3 on the practice exam is an example of Grignard reaction. It proceeds in 2 steps. First, we transmetallate the carbon-halogen bond, meaning we'll insert the magnesium metal in between carbon and bromine. By doing so, we'll reverse the polarity of the existing bond. Here we have carbon atom, which of course has a partial positive charge relative to the halogen, which is more electronegative. So the dipole moment would be pointing toward the more electronegative atom. Magnesium with iodine, where iodine in a small amount is used to polish the magnesium shavings to expose the magnesium that hasn't been oxidized. And typically this reaction is carried out in ether or THF under reflux. So we bring the solvent to boil and we reflux it until the Grignard reagent is prepared. Let's go ahead and draw the Grignard reagent. And the bond between carbon and magnesium really is ionic since we have a metal and non-metal. But if we were to draw the bond, we would see that we have magnesium and bromine. And I'm drawing the bonds just to show you the charge separation. Of course, the bonds between metal and non-metal are ionic. So magnesium, if these were ionic bonds, would be positive 2, bromide would be negative 1, and carbon here would be negative 1 with a lone pair of electrons. So in this example of the Grignard reagent intermediate, so here's our Grignard, the polarity of the bond is reversed since magnesium is less electronegative than carbon atom, and therefore carbon in this example is the nucleophile. This is reminiscent of acetylide reaction, where acetylide ion intermediate formed in situ acted as nucleophile and it would react with an alkyl halide, NeRx, displace the leaving group and form a carbon-carbon bond. So this organometallic coupling, metallic because metal is involved, is another example of carbon-carbon chain extension reaction. So again, the bonds between carbon and magnesium are ionic bonds. Since we have metal and non-metal, there is a full negative charge on carbon atom and a lone pair of electrons. Nucleophilic site on this Grignard reagent intermediate, which again forms in situ, will not be isolated because any exposure to water or aqueous acid would just quench it and serve to reform the benzene ring. The lone pair of electrons will attack the electropositive carbon connected to the halogen, and the halogen will be expelled. So this is SN2 reaction, concerted process in where carbon, negatively charged carbon, attacks the electrophilic carbon in the Rx, and the leaving group is expelled. To help you construct the product, it's a good idea to number the carbon atoms in the Rx in your alkyl halide. So start with the carbon connected to the leaving group and then number the longest continuous chain. So my new bond is between the carbon of the benzene ring and carbon number 1. Here is my benzene ring and I will connect carbon number 1. I have 3 more carbons. 2, 3, 4. I will number those carbons 1, 2, 3, and 4, and then fill in the missing substituents. I have metal group at carbon number 2 and another metal group at carbon number 3. So here is my extended longest continuous chain, and this is organometallic coupling product.